Hello everyone and welcome back to another video. In this video, I'm going to give a final assembly guideline of the radio link Pixhawk drone. So assembling the frame is very simple. Rather, what we'd like to focus here is on how to connect the components, about their synchronization and different other connections. So as you can see, here is my frame and it comes with these types of bottom plate. The bottom plate is, in other words, the PDB or the power distribution board, and with the top plate. I had a spare frame, so from there I'm showing you the bottom plates and the top plates as I've already assembled my main frame. It comes with these four arms and the anti-skid landing gears. And over here you can see that you have the two tubes that are responsible for hanging the battery stand. So the first thing that you need to do is to prepare your power distribution board. This is the positive negative. If you have an XT60 connector, then you have to connect it here. If you have a T plug, then you have to connect it here. It mainly depends on the power module. In my case, the power module comes with the XT60 connector, so I've soldered an XT60 connector down here. Make sure that the quality of the XT60 connector is very good. For example, you can use the AMS XT60 connector. The good fact about these connectors is that they don't usually melt, because when you're going to solder them, of course, it's going to absorb a lot of heat. So there is high chance that the connector may get melt. But if you're using a better quality one like the AMS XT60 connector, then of course there is very low chance that the connector will get melt. And you can see there are 4 of these positive negative pads over here, soldering pads. In these pads, you're going to connect the power input power wires of the ESCs, the 2 wires of the ESCs. Now, if you don't want to solder the ESCs directly onto the power distribution board, then you can take these positives and negatives using a wire and a T plug, and use another T plug. I mean the opposite T plug, with the electronic speed controller or the ESC. If you want to avoid direct soldering of the ESCs on your power distribution board. But I prefer soldering the ESCs directly on the power distribution board. And this is the top plate on top of which all of the components will be attached, mostly by means of adhesive tapes. So the assembly is very simple. The assembly of the frame is very simple. First of all, you have to attach these motors without the propellers with these 4 arms. With these 4 arms, as you can see, the propeller will be connected at the very end, after the calibration, after everything is complete. Only then you can attach the propellers. That is due to the safety purpose. After that, you have to connect or attach the anti-skid landing gear with the bottom plate, and finally you have to connect the top plate. But before that, with the bottom plate, you must also connect these tubes and the battery stand, to hold the battery. That will be later used to hold the battery. So right now I'm going to talk about the assembly of different components onto the frame. The assembly of the frame is very simple. You can do it yourself. Rather, I'm going to talk about the distribution of different components and the way they have been connected with each other. So first of all, the first thing that comes is the connection of the motors. Now, along the right diagonal arms, the counterclockwise motors should be connected. That means the motors should rotate in the counterclockwise direction along the right arm, and along the left arm, the clockwise motors should be connected. So after the connection, after the calibration, if you get to find that the motors, this one should rotate in the counterclockwise direction, but after the calibration you get to see that this one is rotating in the clockwise direction. So in that case, what you have to do is that you have these 3 wires. As you can see, the 3 phases of the brushless DC motor over here. You can see the 3 phases of the brushless DC motors. In order to reverse the direction of rotation of the motor, you simply have to alter between 2 wires. You have to alter the 2 wires, alter the 2 bullet connectors, then you will be all done with the proper rotation. So in this way, you have to check all these 4 motors after the calibration. If you get to see that they are revolving at the opposite direction, then you have to alter any of the 2 phases. You have to swap between the 2 phases, and then you'll see that the motor is rotating in the correct direction. I'm going to talk about the setup on the mission planner and the calibration process of the flight controller and the other components like the radio calibration, the ESC calibration, the IMU calibration, the inertial measurement units like the accelerometer, compass, magnetometers, and so on. So then it comes, the flight controller comes. So it has to be attached at the middle of the bottom of the top plate, and as this is the forward direction, this arrow of the flight controller must be pointed towards the forward direction. As well, for the GPS, as you can see, this is the forward direction of the GPS. This is the forward direction of the GPS, and you must ensure that that it is pointed at the forward direction. And the GPS must be positioned at slightly higher elevation compared to the flight controller for better performance. So I've used a GPS stand, as you can see, to serve this purpose. Then, as you can see, I have attached the radio receiver. As you can see, I have the cell checker down here that will be giving me alarms and the voltages of different cells or the total voltage of my LiPo battery. I'm using a 3-cell 11.1 volt 3200 milliampere hour LiPo battery. Now let's come to the connection. So there are different modules with the flight controller, like the buzzer. You have to connect it over here. I believe that it's visible, the buzzer port. You see, it's right over here. You have to connect the safety switch. You have to connect the power module to supply power to the flight controller. So you don't need any BEC. You don't need any BAC electronic speed controllers. Over here, as you can see, there is an RGB light, that will be giving you indications of different states of your flight controller. So this is the power module. This is the telemetry port that has been connected with the ESP8266 or the Node MCU. This is the safety switch port. This is the buzzer port, the GPS port, and the I2C protocol port, as you can see over there. So the buzzer is attached here with the adhesives. The safety switch is attached here with the adhesives. You can see the cell checker being attached here with the adhesive. And finally, there is my radio receiver attached with the double-sided foam types of tape. At the bottom, you can see this is my power module. This is my power module. This is the main connector that has been connected with the X360 plug, with the power distribution board that supplies power to my power distribution board. And at this terminal, you can see the other end of the battery, which will be connected with this as you can see, the yellow one with this T plug. So depending on your battery type, as you can see that my battery comes with the T plug. So depending on your battery type, you might require to use converters. For example, the X360 female to T plug male. Because my power module comes with the X360 connector, but my battery is type of T plug, so I had to use a converter. And inside the case, there is the ESP8266 as well. That will be used, for Wi-Fi telemetry purpose. These wires will be connected, with the balance port of my LiPo battery for alerting purpose if it is crossing the threshold voltage, if it is going below the threshold voltage. And that's all about a very short brief on the assembly guide. Make sure that the motors are connected properly, and towards the very end, after you are all done with calibration, I'll show you the calibration and the setup in one of the next videos. You should attach these propellers. Now the propellers are two types as well, the clockwise propeller and the counterclockwise propeller, and how you get to distinguish them. So these are self-locking 10-inch propellers, the DJI 1045 propeller. So this motor is counterclockwise motor. You attach the motor on top of the shaft, and if you rotate the motor in the counterclockwise direction, if you get to find that the thread of the propeller is getting locked with the shaft of the motor, if it is tightening, then you get to know that this propeller is a counterclockwise propeller. Otherwise, it is a clockwise propeller. Similarly, the same is applicable for this one. It's a clockwise motor. The propeller should also be clockwise. So you place the propeller on top of the shaft. You rotate the motor in the clockwise direction. If you get to see that the propeller is getting locked with the motor, it means that it is a clockwise propeller. But if it is not getting locked, that means it's not a counterclockwise propeller. It's not a clockwise propeller, I should say. It would be in that case a counterclockwise propeller. So counterclockwise, clockwise, counterclockwise, clockwise. So that's how it works. Along the same diagonal arm, the rotation of the motors must be in the same direction, must be along the same direction. So that's all. If you want to, then you can attach the bottom plate with these 4 legs. Eventually that will allow you to add some additional payloads with your drone. So that's all for now. Thanks for watching. Stay tuned for the next one. Bye for now.